Well, we'll see.
All right, so today we're going to cover new material, chapter 9, and then next week I'll cover just a little bit of new stuff, but it will mostly be kind of going over more of this hypothesis testing, confidence interval, inference stuff, and then so really, I mean, there's new material today. Like a lot of it, okay, and then next week not a lot of new material. So the next 2 weeks will mostly be review type of stuff, and then you'll have the final exam. Okay, so next week we've got a quiz, and it will all be on stuff we did last week and stuff we do today. So you'll still kind of feel a little like you're learning stuff, but then next week's quiz will. Is somewhat similar to the final exam in terms of the structure, but I mean just obviously a lot shorter. And then I don't know. I hope it'll help you guys prepare. I've got a practice final exam posted online also, which should be a good review. And that's it. Okay, so. So yeah, today, well, I just kind of want to get a gauge of how last week's homework and material feels. Is that okay? Not so good?
Got a little confusing on the stat crunch thing.
Okay. Well, the stat crunch is just like punch it into the computer and it gives you a p-value type of thing. So don't worry too much about the stat crunch. But but in terms of hypothesis testing and I don't know the methods and the concepts behind it, is that what?
I don't like the alpha. I never know.
You don't like alpha? Okay, we'll talk about alpha next week and some of the related concepts there. Yes, Rebecca.
I'm confused on how to word the null and alternative. I think that's why I'm getting confused at the end on how to word my conclusion.
Okay. All right. Okay. So these are all valid points. Okay. So I'll try to cover that in detail, and so I've got to balance the time we have today between just making sure you have last week's stuff down and then the new material that I covered today. Okay. So we'll start off with a review problem from the material from last week. Okay. So this will be a two-proportion hypothesis test. There's probably I think you got several items here. Oh, not just you, please. Thank you. Yeah, these also. Okay, two-proportion hypothesis test. So let's see. So I'll write a scenario out, and what I want you to do is to write the hypotheses. And then find p hat, find the standard error, find the test statistic, and find your p-value and conclusion. Okay, so this is what I'll ask you guys to do, and then so let me write out a scenario. Okay. Alright, so we want to know if the proportion of people who, I don't know, watch, what's the show on TV right now?
The Big Bang
is different between, we'll say, men and women. Okay, so let's say we surveyed randomly, so I'll say randomly surveyed 600 men and 500 women. Of the men, let's say 120 watch Big Bang Theory. Of the women, 110 watch Big Bang Theory. Okay. Is this evidence that the proportions are different?
Well, are different or are like surprising? Because they're clearly different. That's why it confuses me a little.
Okay, we'll say that the proportions of men and women who watch Big Bang Theory are different. I don't.
But wait, they are different though. That's what confuses me in the wording. Because like it's clearly gonna be different. Is it like a surprising
Significantly.
difference?
It's about significantly different, isn't it?
Who watch Big Bang Theory are different. Okay, so the question are the proportions in my samples different? Okay, that's not the question. It says, are the proportions, are my samples evidence that the proportions of men and women, so regarding the populations, are they different? Okay, so are the proportions and the populations of men and women different? Okay, proportion who watch Big Bang Theory in the population of all men, and is the proportion of people who watch Big Bang Theory in the population of all women different?
Also, I have a question. Why is it always a different number of samples? Like you've got 600 men and 500 women.
It doesn't have to be.
Okay.
I just happen to pick different numbers there. Okay? I could have picked 500 and 500 if I wanted to, but I didn't.
You want to check the conditions always?
No, all the conditions are met. I'll just tell you that. Okay, so do those 4 things, and I'll give you guys. A chance to get started. How are you guys doing? Step 1, 2, 3, 4. You guys done? Who's done? Okay. You guys getting the right answer? Okay, good, good.
Can you show us real quick how to type in the standard error?
Sure, sure. We'll talk about that. That's good, that's good. Okay. Who wants more time? Who wants me to just do the answer?
No, it's more time.
More time? More time? Okay. I'll give you more
Let's
time.
do this.
So if you get this down, one of the problems on next week's quiz, you'll do fine.
If we get this right,
Yeah, if you get this right. Okay.
You'll get one question.
And there's gonna be like 2 questions, okay?
only two?
Only two?
Yeah, like it's, well, I mean, this is like 4 questions, right? I don't know, it's 1 question with 4
With
parts.
the many, yeah.
Okay, and then, so that'll be the front side of the quiz, and on the back side, it'll be another question with 4 parts.
We're gonna
5
go
parts.
through this, right?
Yeah, of course, of
Like,
course.
wow, okay,
I'm not
good.
just torturing you guys, saying, ha ha ha, this is what's coming.
I won't show you.
I was
though.
wondering, do you change the way like the questions are pretty much like given, like just aside from like the numbers that are given, like how like the questions are, just like what?
Oh, it's
like,
not gonna be
you know,
Big Bang Theory and men and women,
No,
but.
no, no, I mean like just how like it's structured. I mean just like which order, like which formulas for like which like concepts or problems like do we go on? Do you change that for every quarter? As far as the quiz goes? Pretty much
I
just-
try to. Alright, maybe I don't fully understand your question.
Or at least just like completely change like the way the quiz is for each quarter. Quizzes.
I mean, there's only so many 2 proportion hypothesis type of questions you can ask, so. I mean, that's the concept that can test every quarter, so yeah, things will look similar, but I gotta change details of the question. I don't know. Okay. Okay, are we ready? Yes. Okay, let's talk about this. Write the hypotheses. Well, first of all, do we understand what the question is asking? No. Okay. So that's our first problem. Okay. So what we're saying is the proportion of men who watch Big Bang Theory, is that different from the proportion of women who watch Big Bang Theory? Okay. And so to answer this question, we went out and we conducted a survey. And 600 men answered our questions and 500 women answered our questions. These were randomly selected people. When we asked 600 men, do you watch Big Bang Theory, yes or no? 120 of them said yes. Okay? And then when we asked the women, the 500 women, do you watch Big Bang Theory, yes or no? 110 of them said yes. Okay? So if we look at the proportions right off the bat, the proportion of men who watch Big Bang Theory is 120 over 600, which is 0.2, so 20% of the men. And when we look at the women, 110 over 500, that's 0.22, so 22% of women in our samples watch Big Bang Theory. So 20% of our male sample watch Big Bang Theory, 22% of our female sample watches Big Bang Theory, okay? The question is, does this mean that if we generalize these results to the general population, does that mean the proportion of all men and proportion of all women who watch Big Bang Theory, are they different, or could they possibly be the same? That's what we're asking. Is that good?
So we're not asking about the proportion of the sample, we're talking about the all over population.
Yeah, I mean, because there's no mystery about our sample, right? I know that 20% of my sample of men watch Big Bang Theory, and I know that 22% of my female sample watches Big Bang Theory. There's no question, is there a difference between the proportions in my sample, okay? There's no question there. What we're wondering is, okay, this sample of men is supposed to represent the population of all men. This sample of women is supposed to represent the population of all women. So there's a difference between our two samples. Is there a difference between the two populations? That's what we want to know. That's what we're saying when we say, is this evidence, this being our samples, is the data from our samples evidence that the proportions of men and women in the general population are different? Okay, this is an important concept, and so I want to make sure everyone's good here. Alright, so our hypotheses, we have a null hypothesis and we have an alternative hypothesis. So the null hypothesis always has an equal sign. So what are we saying is equal to each other?
But there's no difference.
Okay, yeah, so we're saying that the proportion of men who watch Big Bang Theory is equal to the proportion of women who watch Big Bang Theory. Or this is also equal to saying the proportion of men minus the proportion of women who watch Big Bang Theory is equal to 0. Okay? Either way, totally valid. Okay? On the final exam where it's multiple choice, you might see this, you might see this. So just get used to that. Okay? The alternative. So the null always has an equal sign. The alternative says, is this evidence that the proportions are different? Okay? So when you see something like the word different, that clues you in that we're going to have a not equal to sign. Okay? Because it's not asking, is this evidence that the proportion of men is larger or the proportion of men is smaller? Okay? It's just asking, is there difference? So we're not implying one is greater or smaller than the other. Okay? So either of these would be valid. Those are our hypotheses.
What is it in words?
What is it in words?
Yeah, the null.
The proportion of men and women who watch the Big Bang Theory are equal. What season is that show on anyway?
I love it.
It's the greatest show?
think it's
Is it on Tuesday nights?
Yeah, it is on Tuesday.
Okay. My favorite show is So You Think You Can Dance, but it's always
Oh, I love
on
it.
the during a day I teach. So
But you can go online and watch it.
yeah, well,
So
I don't know. You
intense.
have to like
We
subscribe
can all
to
just
cable
watch
or
it, you
something.
know.
Just
We
record
just
it.
watch it with everyone.
I know.
Are you guys amazing?
Huh?
Watch it right now.
Let's watch it right now.
Yeah.
And we'll talk about the scoring here. Okay. All right. So these are our null and alternative hypotheses. Okay. Portion of men and women who watch Big Bang Theory are equal, and portion of men and women who watch Big Bang Theory are different. So now we want to know. Okay, we got to figure out p hat and the standard error. Okay. So p hat is the overall proportion. So we have 120 men who watch Big Bang Theory and 110 women who watch Big Bang Theory, for a total of 230 people who watch Big Bang Theory, divided by how many people total do we have? We have 600 men plus 500 women over a total of 1,100 people. Okay, and this is equal to 0.2091. The standard error is going to be equal to the square root of 0.2091 times 1 minus 0.2091 times 1 over 600 plus 1 over 500. When you punch this into your calculator, you should get 0.0246.
You just did multiply by 2.
So,
Divided by 600 from 500, right? Can't you just put that over all of it? Like, well, it just looks a little. It looks different from what you usually do, but it's the same thing, right?
Is it different from what I normally do?
Well, no, I mean it's times 1 over, but can't you just put that over 600 plus 500?
Times 1 over?
You can just divide it by 1100 instead of.
You
Yeah,
cannot divide by 1100.
This is why.
Huh? What's 1 over 600 plus 1 over 500 is not 1 over 1100.
No, yeah,
Okay.
that's
Yeah,
yes.
but-
Okay, wait. Is this not what I taught you guys?
You used to put it. We used to have us put it over
The total.
something, yeah.
Is it different or is it the same?
It's the same.
It's the same. I'm pretty sure this is what I've been teaching this whole time. Okay?
it is the same actually. Even though I remember.
If I've done something different, I apologize, but I'm pretry sure this is
Okay,
this
wait,
is how
so-
I have it in my head. So
wait,
I don't
and
know why I
what
would.
is that? One. Oh man.
Okay, so alright, so I know there's people who are like, how do I do this on my calculator, okay?
Yeah.
So we'll go through it and I'll tell you all the buttons to push, yeah.
Wait, so then what is the? Can you say the formula out loud then? Because I mean, I thought I had the formula correct. Oh, I didn't get that formula for some reason. I must have missed it.
You know how to leave it on?
Leave this up?
Yeah.
Let's do
Okay.
this.
Alright, so shall I tell you what buttons to push on your calculator?
Yes.
Alright, okay. Do you guys have a scientific with a
Yeah.
parentheses button? Okay, because this is going to be
Is
important.
it different if we have this time?
No. Okay? If you got a parentheses button, just look for the same buttons that I'm putting up here. Okay? And then you should also have an answer button somewhere, or maybe a second answer button. Okay, so we'll do this. And depending on your calculator, you might have to do square root and then the answer, or you do answer and then the square root. Okay? So that might be different depending on your calculator. But we'll okay, so I prefer no rounding whatsoever, okay? And I just leave it all in the calculator here, and I'll show you how I do it, okay? So what I do is first I get p hat, and I do parentheses, open parentheses, 120 plus 110, close parentheses, divide, open parentheses, 600 plus 500, close parentheses, equals. Okay, and that gives you 0.2091. It should.
Okay.
I didn't know there were parentheses.
So, you got to know your PEMDAS, right? Order of operations.
Oh no, I just didn't know that you could do the parentheses calculator.
It's show me this here.
You don't
It's
even need to know
brackets.
Yeah, I just didn't think to press those buttons.
Yeah, well, you gotta make sure.
So that should
and
give
you-
us 0.2091?
0.2091, okay, that's when you round it off. And then the next thing, so what I do is using the answer key, or you have to use second answer.
Where's that?
Answer times parentheses 1 minus answer, close parentheses, times open parentheses 1 divided by 600 plus 1 divided by 500, close parentheses, equals.
Why are you using the p hat? Oh right, yeah,
Because,
yeah. Got it.
so this is going to give me 0.2091.
Got it.
This is now the answer.
Right.
Okay, so every time I put an answer here, that's going to be what p hat is.
Okay, let's see.
Okay, this is now my new answer. So alright, so let's follow along here.
0006.
Oh, okay.
1 divided by 600? You mean 1 over
Okay,
600?
so this, huh?
Isn't it 1 over 600?
Yeah, well 1 over 600 is the same thing as 1 divided by 600.
Oh, okay.
Okay, so right now you have something crazy like 0.000606,363.
What do you have, and so what do you have after the equal sign?
An answer. This is my new answer.
What'd you get? I got this.
0.0006.
0.000606363, right?
Got it.
Okay, now hit the square root button and then answer.
0.0246244.
There's your standard error.
I
Okay.
don't think we're writing that down.
So we just gotta remember to round.
0.0246244. No, you don't have to do any kind of rounding at this point. You still don't have to do any rounding. You can leave everything in your calculator and just keep using the answer. I mean, if you're comfortable with it.
Yeah.
If you hate it, then don't do it. But I'm just showing you exactly what sequence of
But if we
buttons you
do
press.
round, it's okay.
If you do round, that's fine.
Make sure you round correctly.
Just make sure you round correctly. Exactly.
So, obviously, you need to know how to use your calculator.
Yeah, I mean, if you can't use your calculator, you're in trouble. That's true. That's true.
That's true.
Yeah, you do.
But I don't think
Huh?
you got the 2.6.
Okay. So maybe you have to do second answer on your calculator, but it'll do it. Okay. All right. Are we good? Everybody has this as their standard error.
Yeah.
Okay. So now we can get our test statistic.
I wasn't done.
Sorry. You can go back and watch the video and pause it.
Maybe that's it, 2 hours.
Okay. So what is our test statistic?
Step 4.
Okay, so I'm going to take the difference between P1 hat minus P2 hat.
This is step 3, right? Or-
This is getting our test
Step
statistic, yes,
4.
part 4, divided
Oh,
by
sorry.
the standard
Step
error.
4.
This is how I get my test statistic, correct?
Yes.
Okay, so this is equal to P1 hat, which is 600 men divided by, I'm sorry, not 600 divided by, it's 120 men divided by 600, minus the proportion of women, which is 110 over 500, okay? And then I'm going to divide this by my standard error. You haven't cleared out your calculator, is that correct? You still have 0.0246244
Yeah.
something in your calculator? Okay, so on your calculator, hit parentheses 120 divided by 600 minus 110 divided by 500, close parentheses, divided by answer button equals. Okay. Sure, okay, then you can just do 0.2 minus 0.22 in parentheses.
Yeah, I'm just.
Minus 0.81?
Hmm? Yeah, negative 0.81.
Yeah.
Okay? And so that is my test statistic, okay?
Z.
Negative 0.81. So my test statistic, or my z-score, is equal to negative 0.81. Okay? Negative 0.8122. But again, we're looking this up in a z table, so you've got to round off to 2 spaces. John?
I'm getting negative 8.1.
Negative 8.1?
Yeah.
You-
That's what.
0.02
Oh.
minus 0.22 divided by .0246.
I think you got to do 0.2 minus 0.22, not 0.02
Well, not
minus.
0.02.
Yeah, it's going to make a difference.
Anyway, so can I ask you a question? The test statistic, the formula is different when it's one proportion.
Yeah, for one proportion it's different.
Yeah, it's observation minus null.
Yeah, minus the null. Yeah.
So this is the formula for the two proportion.
For two proportions. So keep track of these things. Yeah.
Yeah, I need to. So it's P1, P hat 1, P hat 2.
Okay.
Where is P hat 2? Where do we get that from?
P1 hat and P2 hat.
Oh, that's just a proportion?
Quick question.
Yes.
Are you keeping this number,
So this is my standard error.
right, you're keeping that in as you go into the.
Yeah, I'm just leaving that in there, okay? So at this point I can stop. This is my test statistic, negative 0.81. So now I go to the Z table. Boy, are we okay? Are we all getting negative 0.81 on our calculator? Or we've given up or something? I don't know.
Sir, can I ask you a question? So this is the answer to the standard error?
Yes.
So you want me to work from there onwards?
Yeah, and leave that in there, and then just do this.
I just do a bracket now? Parentheses?
Parentheses 120 over 600 minus 110 over 500, close parentheses divided by
Alright,
answer. So that's going to keep, because the answer right now is equal to my standard error. See, it's kind of like a little puzzle, right? You just keep, and then you've got this one box which is your answer key, and try to sequence things. So.
Oh, scheiße.
Okay, so the p-value, are we okay this far?
What should I be getting? Minus 8?
Negative
Yeah.
0.81.
Okay, got it.
So the decimal point that I got, it's past the 1,000.
I don't know what happened, okay? Alright, so because my alternative has a not equal to sign here, I'm looking up the area in this tail and I'm going to double it. Okay? So when I look up in the table how much is over here, it tells me 0.2090. Looking up Z equals negative 0.81. And then now I double that because it's a not equal sign. If it was a greater than or less than sign, I would just leave the tail as is.
So you times
The 0.2090 by 2, and I get a total p-value of 0.4180. Yes.
So when it's a not equal sign, we always do the, we always do it times 2, but when it's
Yeah.
Greater than or less
So if it's
than,
less than, you always take the area to the
1
left.
minus the-
Okay, if the alternative has a less than, you always do the area to the left. If the alternative has a greater than, always take the area to the right.
Okay, and then to find the p-value, we always do 1 minus what we find in the.
No. So if
If
the hypothesis is less than, always take the area to the left. That's your p-value. If the hypothesis shows greater than, always take the area to the right. That's your p-value. If the hypothesis is not equal to, take the tail and double it, and you will have the p-value.
when it's
Okay?
two proportion.
That's not what I asked.
You said about the 1 minus, right?
No, right, I'm saying if it's a less than or equal to, we're gonna see that, let's say, we're gonna see it on the table, we're gonna see the number on the table, the z-score, right? We're
Yeah.
gonna see it on the table.
Yeah.
To find the p-value, we're gonna do 1 minus that.
No,
minus
if it's a less
the
than or
rest of
equal
it.
to, you're going to take the area to the left, which is just what's given in the table.
So in this problem.
Okay, we have a question back there.
On the right side, is that a negative 0.81?
It's a positive 0.81. Okay? But how much is to the left of negative 0.81? 0.2090. How much is to the right of positive 0.81? No, it's exactly the same, 0.2090. Okay? This is, how much is over here? Also 0.2090. Okay? This is a fundamental property of the normal distribution. Okay?
What will you double it?
I'm doubling 0.2090. Okay?
So in the two proportion problems, we don't do 1 minus whatever, just take whatever that is.
Whatever this number is, okay, well, I mean, look up the tail, right?
Yeah.
If you're going to look at positive 0.81, then you've got to do 1 minus to get the tail. Because if you look at positive 0.81, the table always gives you the area to the left. The table always gives you the area to the left. So you always have to be fully aware of what's happening. So my p-value is 0.4180.
I got like only a 141.
Okay, 418.
418, yeah.
That's fine. I mean, you can add on as many zeros as you want after that. Okay? And so, if my alpha, let's say my alpha was 5%, 0.05, is my p-value bigger or smaller than alpha?
Smaller.
My p-value
Oh no, sorry,
bigger
bigger,
than
bigger,
alpha.
bigger.
Okay? P-value bigger than alpha, what do we do?
We reject this now.
We do not reject the null hypothesis. We do not reject the null. It means, so what does this p-value of 0.418 mean? Let's say it's 42%.
Say that 42% of the time there's only going to be 2%.
Okay, so this 42% means if the null hypothesis were true, what is my null hypothesis? That the proportions of men and women who watch Big Bang Theory are the same. So if truly the same proportion of men and women watch Big Bang Theory, whenever I take two samples of 600 and 500, I have a 42% chance of getting a proportion difference of 2%, which is what I observed, right? I get a 42% chance of seeing a 2% difference just because of random sampling, just by random chance. I don't need any other outside influence to give me this 2% difference. So does it seem like the 2% difference that we got in our data, does it seem like it could have happened by random chance? Or do we feel like this is evidence that the proportion of men and women who watch Big Bang Theory are different? It could have happened by random chance. It happens 42% of the time. So it definitely could have happened.
So
by
therefore,
random
that
chance.
means there's a possibility where they could be the same.
Yeah,
And
there's
then-
definitely a possibility that they could be the same.
Okay. Therefore, do not reject that.
So don't reject them. Yes.
Can you say that again? For some reason, the only thing that confuses me about this is like rejecting the null, and so okay, because the p-value is.
So, all right, once again, because my p-value is greater than alpha, which I have specified to be 5%, I do not reject the null. Anytime your p-value is bigger than alpha, you do not reject the null. And so that means we do not have evidence that the proportion of men and women who watch Big Bang Theory is different.
So why though? Why is because the p-value is larger than alpha? Why?
So what we're saying is, so did you understand what the definition of the p-value is, or what it means?
Well,
So
it's
there-
I know to be the area that you're looking
Okay.
for. In the
So what I'm saying is, if the null hypothesis were true, the probability of me getting a 2% difference in my samples, which is what I observed, the probability of that happening just by random chance is
really small.
42%.
Okay.
It's going to happen quite a bit. Okay? It's just like if I flip a coin 100 times and it lands heads 52 times. Okay, nobody would say, man, you've got a coin that's biased towards landing on heads, right? Because the probability of it landing 52 heads out of 100 is pretty great, even if it's just a regular old fair coin. That's what we're saying here. Even if the proportions of men and women who watch Big Bang Theory are exactly the same, the probability that I see a 2% difference just by random chance is pretty great. That's 42%.
Okay, so what that's saying is that just because like there happens to be more of like men or women.
Yeah.
Okay, I get
I
it.
happen to have a few more women who watch it. 22% of women watch it in my sample versus 20%.
Okay.
Is that 2% difference a big deal? According to this, it's not. Yeah.
So
Suzanne.
in order for us not to reject the null hypothesis, we need to have p-value greater than that 0.05.
It needs to be less than 0.05.
That's greater.
If we want to reject the null,
Okay.
we have to have a p-value less than 5%.
And that's always, right?
Yeah, the p-value has to be less than alpha if you want to reject the null. Grace.
Yeah, can you explain one more time, when you say we don't have enough evidence? Once we reject, no, when we do not reject the null because we don't have enough evidence.
Yeah, so
That's
what
just-
is my evidence here? What is my evidence?
The difference is 2%, 40.
Well, that's what I'm not understanding.
So my evidence is I surveyed 1,100 people. I did a lot of work. I surveyed 1,100 people. I mean, it wasn't a lot of work because I just made up numbers, but okay. According to this, we did a lot of work. We surveyed 1,100 people, and then 110 of the women said they watched Big Bang Theory, and 120 of the men said they watched Big Bang Theory. But I happened to survey a lot more men than women. So overall, the proportions was 20% of the men watched Big Bang Theory, 22% of the women watched Big Bang Theory. Okay? This is my evidence. I'm getting 20% of men, 22% of women watching the show.
The difference is only the 2%.
There's a 2% difference there, okay? That's what this number here is,
Yeah,
okay?
okay.
Now, maybe that's lost in the formula.
So is that what we should look like at the very end when we're writing it out, as far as numbers go? Like the 22 versus 20%?
Yeah, I mean, that's what we're asking from the start. We're asking 22% versus 20%. There's a difference, right? 2% difference. Is that 2% difference a big deal, or is it not a big deal? Okay? And when we do the math, it turns out when you surveyed 1,100 people, the 2% difference is not a big deal.
And the evidence is that the p-value is larger than alpha.
Correct.
Yeah.
Yeah. Now, if we surveyed 1 million people and we get a 2% difference, maybe that's a bigger issue. Okay, but with 1,100, the 2% difference is not a big deal. Yeah.
Are we always gonna get different alpha or?
That's
the most common one, right?
5% is the most common alpha, but I could specify a different alpha if I wanted to.
Like
Yeah.
one from
Or you could also. Yeah.
Yeah.
All right. Is this okay? Please study this. I mean, we spent quite a huge chunk of our class time on this, so go over it. Okay, you'll see something like this on the quiz. We can't spend an hour going over it on the quiz, but yeah. So my p-value is 42%. Okay, that means if the null hypothesis were true, meaning there was no difference in the proportions of men and women who watch Big Bang Theory, 42% of the time, just by random chance, I would get 2 samples that exhibited a 2% proportion difference, which is what my data showed. 2% or more. Okay, that took a little bit longer than I wished. Let's